Hello everyone, welcome to Anand Sir YouTube channel. Today we are going to learn about assumptions in limit state of collapse, that is in flexure. So this topic is related to RCC, that is reinforced cement concrete, and today we are going to list out various assumptions that we should study before designing of a singly reinforced beam or doubly reinforced beam. So let's start. So first assumption is that the plane section before bending remains plane even after the bending. That means uh, the strain at any point on the cross section of the beam can be directly calculated using the distance of that section from the neutral axis. Okay, so the variation will be linear. So here I have shown in the right side diagram that if strain at the top fiber is 0.035, so here we can calculate the strain by using the concept of similar triangles. Okay, the second assumption is that the maximum strain in concrete at the outermost fiber is taken as 0.0035 in bending. And the third assumption is that relationship between compressive stress distribution in concrete and strain in concrete uh, may be assumed to be rectangular, trapezoidal, parabolic, or any other shape which results in prediction of strength in substantial agreement with the result of test. That means ki if we plot a graph between sigma and epsilon, then we will get some portion of the curve as parabolic and some portion of the curve as linear. So the result of that test will help in prediction of strength, and that prediction can be uh, guessed on the basis of shape of the curve. Okay, so this is linear curve, and for the first curve we will use fck, for the second we will use 0.67 fck, and for the third curve we will apply the partial safety factor of 1.5 and we will get 0.45 fck. Okay, and using the above curve we can calculate stress block parameter for the above curve. Okay, so if we assume a cross section having a width of b and depth d, and at the bottom we are providing some steel having area as ast and neutral depth at xu. So using this cross section we will first draw a stress diagram and then we will draw a strain diagram. Strain diagram and stress diagram will help in calculating the stress block parameter, that is total compressive force and the related neutral axis depth. Okay, so let us try to calculate the total compressive force and then neutral axis depth. So from the strain diagram, we using similar triangle we can write 0.0035 upon AC equal to 0.002 upon AB. Using and simplification this we can calculate easily. AB is equal to 4 by 7 XU, and since uh, from neutral axis to top fiber we have A, B and C. So this distance is XU, and if AB is 4 by 7 XU, so this portion will be XU minus 4 by 7 XU, so that will be 3 by 7 XU. So BC will be 3 by 7. And to calculate the compressive force, we will calculate like this. So for there are two shape here, one is linear portion and one is parabolic. So for linear portion, we will apply rectangular area multiplied by width of the cross section. So width of the cross section is 0.45 fck, sorry b, and here rectangle length is 0.45 fck, and this portion is 3 by 7 sq. So here 0.45 fck multiplied by 3 by 7 sq into width of cross section is b. So c1 we will get as 1 by 0.193 fck x ub, and this force will act at a half of distance of the breadth of the rectangle, that is 3 by 7 half, that is 3 by 14 xu from the top. Similarly we can calculate c2. So area of parabola is 2 by 3 into base into height. So if you apply 2 by 3, base is 0.45 FCK, height is 4 by 7, and width is B. So we will get C2 as 0.17 FCK SUB. And this force will act like this. Mm, it will take this much distance, and it will take 3 by 8th of total distance of 4 by 7. So 3 by 7 plus 3 by 8 into 4 by 7 xu. So this will on simplification give y2 as 9 by 14 xu from the top fiber. Now to calculate the combined force, we will simply add C1 plus C2, and by adding C1 plus C2 we are getting 0.36 FCK XUD. And now to calculate the CG of this force, where the combined effect of C1 and C2 will act, we will apply a formula like y bar is equal to C1 y1 plus C2 y2 upon C1 plus C2. Putting all the values and simplification, we will get y bar as 0.42 XU. So Z will be equal to, that is lever arm will be equal to D minus 0.42 maximum. The fourth assumption is the tensile strength of concrete is ignored because concrete is not very good in taking tension, and it is very good in taking compression only. Fifth assumption is for design purpose we take partial safety for steel as 1.5. The sixth assumption is that maximum strain in tensile strain in the section at failure shall not be less than EST equal to Fy by 1.15 PS plus 0.002 or 0.87 Fy upon ES. So as we know, for steel, ES is equal to 2 into 10 to the power 5, and for different type of steel like Fe250, Fe415 and Fe500, upon putting the value of Fy 250, 1415 and 500, we will get corresponding value of EST as 0.0031, 0.0038 and 0.0042. So what does that mean? That maximum strain in tensile reinforcement in the case of steel having Fe250 bars should not be less than 0.0031. Okay, so that's all for the assumptions in limited state of collapse, that is flexure. Thank you for watching this video and have a nice day.